Welcome to today's session. In today's session, we'll see branching instruction of 8051. Okay, and they are used to flow to transfer the program execution. Okay, the flow of program execution will be transferred depends on conditional or unconditional. The very first instruction we'll see a call. It is an unconditional jump in which the content of PC will be changing. Okay, how the content of PC will be changing? Okay, let us take with the example here. A call LOC underscore sub means this is a one instruction. Okay, a call. Okay, let me take now LOC sub is located at the location 0567, that is this location. Okay, now my a call will be stored at location 0230H, means initially PC will be loaded with this address. When the instruction is executed a call, now PC is executing content of 0230H. Immediately when it sees a call, it has to jump to the location called 0567. Okay, this 0567 will be loaded into PC, and by meantime 0230, okay, this will be pushed onto stack. Okay, 0230. Okay, means PC will be loaded with 0567. Okay, and the current instruction location 0230 will be pushed onto the stack. How it will be pushed? Okay, this will be pushed at location 08 and this will be pushed at location 07. Means content of 08 is 30. Content of 07, sorry, this is 09. 09 will be 02. The next instruction is L call, means is a long call, means the program counter will be jumping to the location which is more than 2 kilobyte, means it will be go up till 64 kilobytes of program space and not affecting any of the flag. Okay, as a similar here. Okay, now initially the content of SP, okay, there is a 07 because stack pointer, as I told, stack will be pointing at the location 07, and this LOC is located at the location 02034. Okay, and currently executing the program, that is 0230H, means current program is executing at the location 0230H. Immediately when it finds L call, it will be go to the location 0234H. This is a return instruction. This instruction returns the program from a subroutine, that is return pops the high byte and low byte address of PC from the stacks. Means previously, okay, whenever the instruction call is occurred, the current PC values are stored onto the stack. Why it is stored onto the stack? Because the program is temporarily suspended after executing the subroutine program. Okay, after executing the subroutine program, it has to be pop back the previous PC value. Okay, how it will be does? From the return values. Okay, this is a similar to the previous one. In fact, the subroutine program is executing depends on interrupt. Okay, whenever the program is executing, if specific interrupt is occurred, the current program will be suspended. When it suspend, the PC will be again, it will load the current location address onto the stack, and it will go to the specific location. After executing the subroutine program, again it will come back to the main program. Okay. How it will come back to the main program? When it sees the instruction return I. During this time, it will give back the previous PC values that those are stored onto the stack. Again, it will be loaded into the PC. Okay, that is the next instruction is AJump, A address 11. There is a location. AJump instruction transfers program execution to the destination address, which is located at absolute short range distance. Okay, between means it will be between 2 kilobytes of location address. Okay, there is the same here. There is a label near is at the location 0120h. Means my near labeled instruction is located at 0120h. Whenever it sees the instruction AJMP, the program PC will be loaded with 0120h. Okay, my AJMP is stored at 0234h. Means PC will be loaded with 0234h. Okay, now whenever it sees, it has to go to the location called 0120h. Means PC will be loaded with this address. Where this will go? It will go onto the stack. Okay, after completion, again it will take from the stack. Okay, it will be loaded into the PC. Long jump. Long jump, okay, in fact is a far jump, that is jumping to the location up till 64 kilobytes of memory location. Okay, in which FAR underscore ADDR is located at the location 3456h. Okay, and LJMP instruction is at the location 0120h. Okay, when the instruction is executed, the PC will be loaded with 3456h. Okay. SJMP short jump is a short jump instruction in which the PC incremented by 2 and then adds the relative value. Okay. This will be the new address where the program would branch to unconditionally, and the range of short jump will be between -28 to +128 bytes. Okay, the similar here, the labeled instruction REL SRT is located at 0. This will be at this location, this instruction 0120h. Whenever SJMP is executed, the PC will be go to 0120h, and now PC will be loaded with 0120h. Jump, okay, JMP at A plus DPTR means here whenever it is jumping to the specific location, it will add content of accumulator plus DPTR. Okay, so how it will does operation here? Let me take content of accumulator will be 02. Okay, and content of DPTR will take with some value. dptr will be 1000. Okay, now dptr is loaded with 1000. Okay, 1000 plus 2, 1002 means jump. It will go, which location it will go? It will go to 1002 location and it will execute the instruction. Jump on 0 relate to jump if content of accumulator is equal to 0, means it will go to the specific label if content of accumulator is 0. Let us take with the example here SUBB A, 20H, means it will subtract 20H from the content of accumulator. After the subtraction, if the content of accumulator is 0, it will go to the location label 1, or else it will go to the next instruction. Remember this operation is always with respect to the accumulator, means content of accumulator is 0, then only it will jump to the location. Jump on no 0 is just a complementary operation, means content of accumulator is not 0, then it will jump to the specific location. Okay, let us take, and one more here, both the instruction jump GZ and DJNZ are not affecting any of the flag. Okay, let us take with the example here decrement A. Okay, jump on no 0 label to move R0, A. If content of accumulator, let me take example here 05H. Okay, decrement A. Okay, 5 minus 1, it is 4, it is not 0, means when it go to the jump on no 0, what is the content of accumulator? 04, it is not 0, it is not equal to 0, then it will go to the label 2 instruction, or else if this is 0, it will go to the next followed instruction, that is move instruction. The next instructions are jump carry, jump on no carry, means it will go to the specific location if carry flag is set, and if carry is equal to 0, that is jump on no carry. CJNE destination byte, source byte, that is a label. In this instruction compares the magnitude of the destination byte and the source byte and branches if their values are not equal. Okay, that is the carry flag is set if the unsigned byte is less than the unsigned integer source byte, otherwise the carry flag is cleared. Okay, the very important is that both the operands are not affected with any of the values. Okay, what's the meaning of this? Okay, let me take initially content of R3, I'll take here 50. 50 will be compared with 50. Now compare jump not equal. Okay, they are now equal. Okay, it will find a false, it will go to the next instruction. Okay, now let me take with the second way. Content of R3 will be 20. Okay, now 20 is less than 50, means 50, that is 50 is subtracted from R3, then CY will be set to 1. CY is set to 1. Okay, now when CJ and E, they are not equal, where it will go? It will go to the location NEQU. Okay, now when it go to the NEQ, that is jump on carry. Okay, the corresponding instruction is executed. Okay, let us take with the R3 with 70. Okay, that is 70 will be greater than 50. So they are not equal. Carry will be reset to 0. Okay, there is a few instructions how we can use a CJNE. Okay, the very first one, content of accumulator is compared with immediate data. If they are not equal, it will jump to the location called target. There is example, content of accumulator A, if it is not equal to 96, go to the next instruction. Okay, the next one, CGNE A comma direct comma target, means content of accumulator is compared with content of memory location. If they are not equal, it will go to the location called target. That is CGNE A comma 40H. Content of accumulator will be compared with content of 40H. If they are not equal, it will go to the location next. CJNE RN comma data target, means content of register is compared with immediate data and jump to the location called target. Okay. Similarly, CJNE @RI comma hash data, means the data pointed by R1 will be compared with 80. If they are not equal, it will go to the location next. The very important is that the target address not more than 128 bytes forward or 127 backward, and you need not worry about this. It has to be between these locations. Okay, the next instruction, DJNZ byte comma relative addressing, means this instruction is decrement jump, not 0. It decrements the contents of the destination location, and if the resulting value is not 0, branches to the address indicated by the source operand. An original value of 00 underflows to FFH, and no flags are affected. Okay, the meaning of this, now the example, DJNZ 20H comma LOC1, means content of 20H, okay, will be decremented by 1. Okay, if it is not 0, go to the location called LOC1. Okay, similarly, content of 30H is decremented by 1. Okay, if not 0, it will go to the location 2. Similarly with the 40H. Okay, that is what we are given. The content of 20H will take here 1, content of 30 will take here 5F, content of 40 I took here 16H. Now content of 20 in the first one, it will be decremented by 1, it is 0. Okay, means decrement jump on no 0, means decremented with 0. If it is not 0, then, but here in this case is a 0, where it will go to the next instruction. Okay, if it is true, then it will go to the location 1. Okay, similarly 5F is decremented by 1. Okay, it is not equal to 0, then go to the LOC2 label. 16 will be decremented by 1, that is 15. It is also not equal to 0, it will go to the location called LOC3. Okay, that is how the DJNZ will be supporting. DJNZ RN comma target, means content of R3 will be decremented by 1. If it is not equal to 0, then it will go to the location called here. Okay, the very important is that R3 will be affected with like a changes. Okay, the next one, DJNZ direct comma, there is a location we have to mention here, means content of 40H will be decremented by 1 and it will jump to the location called next. That is, this is not a direct, this is next. Okay. The next instruction, NOP. Okay, this is a no operation instruction, means the instruction takes one machine cycle operation. Okay, there is a one machine cycle operation time. Okay, this is useful. Okay, in the coming classes I will discuss about this more. Okay, hence it is useful to time the on or off bit of an output port. Okay, means it is a zero operand instruction, just it will consume a one cycle of operation. Okay, it has nothing to do with any, just it is consuming one cycle. Let us say this will take one cycle time for execution. This will also take one cycle, one cycle, one cycle, one cycle. Okay, the very first instruction is CLR, the next instruction is set B, I'll say. Okay, whenever it is executing, the time between CLR to set B, okay, there are the how many cycles will be lapsed here? 1 2 3 4, means total 4 cycles will be lapsed, means waiting. You are giving a time for the next instruction to be executed after 4 cycles. Okay, you'll come to know, okay, in coming classes. Okay, this is what about the few of the instructions in which conditional jumps and unconditional jumps are supported here. Okay, this is just a brief summary of today's instructions what we are given. Okay, I hope it is clear from the today's session. Okay, in coming class we will discuss more on programming tasks related to the instruction what we have covered here. Thank you.